Hi, today I'm going to show you how to solve problem 28 from the 2017 Math Kangaroo grades 5 to 6. Here's the problem. John wants to write a natural number in each box of the diagram in such a way that each number above the bottom row is the sum of the two numbers in the boxes immediately underneath. What's the largest number of odd numbers that John can write? So for example, the number in here is going to be the sum of the numbers here. The number here is going to be the sum of the numbers here. So we don't need to know what the numbers are, we're just looking whether they're odd or even. So we can write odd numbers as O and even numbers as E. And we know that if we have an odd plus an even, that gives us an odd number. And if we have an even plus an even, that's an even number, and an odd plus an odd is an even number. So these are our options. And we're trying to have as many odd numbers as possible in the diagram. So why don't we just put odd numbers in the entire bottom row? And then we'll be having as many odd numbers as possible in the bottom row. We can see what happens. So if we put odd, 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 well then we have an odd plus an odd that gives us an even. An odd plus an odd gives an even there. An odd plus an odd gives an even there. And then we have two evens give us an even. Two evens here give us an even. And then these two evens give us an even. This doesn't seem like a very good result. We have odds in the entire bottom row, and then above that it's only evens. So there's probably something better we can do than this. If we start at the top row, we can say which one we want that to be, and then we can work down to try to make there be as many odds as possible in each row. And if we do that, we'll make sure that there's some odds in each row and as many as possible, which might give us more than if we just focus on the bottom row. So let's say we make the top one an odd. Now, to get an odd, we need to have an odd and an even. It doesn't matter how we align them because the thing is symmetrical. So we can put odd and then even. Now, to get an even, we need either two evens or two odds. But we want to maximize the odds. So we're going to put two odds here instead of two evens. And then to get the odd, we'll have to have an odd and an even. Again, here we have an even. We'll want to put two odds to get that even as opposed to two evens. To get this odd, we'll need an even here, and then to get this odd, we need an odd here. And if we count, this gives us 7 odds. Which is a lot more than the 4 we were able to get before. And is it the most odds that we can get? The answer is yes. We have some odds in each row, and we're maximizing the number of odds we can get in each row. If this one was even, we wouldn't be able to get as many odds, and we can see that. But if we assume this one to be odd, then in each row we are trying to make every possible box that can be odd an odd. And so that's as many as possible. Now if we have an even at the top, then we would want to have two odds. And under the two odds, we would want to have an odd on each side and an even in the middle. The other option would be an even on each side and an odd in the middle. But this way gives us more odds. And then in the final bottom row, again we would have two odds because of the even. And then we'd have to put two evens on the other sides to get the odds. And if we count, this only gives us 6 odds. That's less than the 7 odds we got here. And so that shows that this is going to be the most odds we can get. So the answer is D. Thank you.